Hi there, welcome to edupediaworld.com. You're watching the videos on statistics. So in this video, we'll discuss the concepts and the questions related to presentation of data, the concepts we have discussed in the previous videos. So we will be discussing the further questions, how to solve various types of questions, how we can represent the question, how we can represent the data in a presentable form. So let's discuss the first question, which is question number 1. Now, the question says that the blood groups of 30 students of class 8 are recorded as follows. Let's say A, B, O, AB, O, A. So these are the following blood groups, and you can notice very clearly there are 4 different types of blood groups, that is A, B, O, and AB. You can see properly, this is A, this is O, and this is AB, right? And this is B. So there is no other repetition or combination like OA or like AO, right? So these are the only 4 blood groups available, right? Now, we need to represent this data in the form of frequency distribution table. So we need to draw a frequency distribution table, which is the most common, and you know how we can draw the frequency distribution table, right? And we have to find which is the most common blood group and which is the rarest blood group among these students. So let's discuss how we can do this question, right? So for this, we need to draw a table. So let's draw a table like this. Let's say we have table like this, right? Now, this is the thing. So let's write over here blood group, and let's write over here the number of students, right? So number of students, it will be the frequency, right? And the blood group is which blood group is repeating by how many times. That's a frequency, right? So we have 4 different blood groups. Let's say this is A, B, O, and AB, right? Now let's count for A. How many A's are there? So this is 1. Let's say this is 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 A blood group students, right? So we can write under the number of students or the frequency column, we can write 9 because the number of students having a blood group A are 9. Similarly, for B, we need to count. So let's say this is 1, right? This is 2, 3, and we have 4, and we have 5 and 6. So we have 6 students under the blood group B, right? So we need to write 6 over here. Similarly, for O, we need to count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So under the blood group A, O, we have 12 students, right? Now let's count for the last one, which is AB. So this is 1, this is 2, right? Any other, you can search properly, and this is 3. So 1, 2, and 3. So this is the 3 blood groups of the students AB, right? So we can write 3 over here, right? Now we need to write total over here, and we need to add the number of students, right? So we can add 9, 6, 12, and 3. So this will be 2 plus 3 is 5, 5 plus 6 is 11, 11 plus 9 is 20. So it will come 0, and 2 will carry over here. 2 plus 1 is 30. So we have total number of students are 30. So, and this is the frequency distribution table. Now, how we can check that the table is right? So you have to match this total of frequency with exactly the number of students given. So if you can see properly, there are 30 students in a class, and for the sum of frequency, we are also getting 30 students. So this means our distribution, frequency distribution chart is correct. So this is how we can use the concept to represent the data in a readable manner, right? So let's move on to the next question, which is question number 2. The question says that the distance in kilometer of 40 engineers from their residence to their place of work were found as follows. So this is the distance of, let's say, every engineer travels, right, from residence to their work of place, right? And this is the distance, individual distance, let's say 5, 3, 10. These are the individual distances given by the each of the engineer traveling to the work from their house, right? Now, so what we need to do is we need to construct a group frequency table, right, with table class size 5. So we need to have a class size 5. We need to make a note of this for the data given above, taking the first interval as 0 to 5. 5 not included means upper class is not included. What main features do you observe from this tabular representation? So we need to write our, let's say, representation, like which is the highest, which is the common. So we need to represent the data like this. So let's do it, how we can do this now. So first of all, we need to have a class size 5, right? And it starts from 0. So this means we need to start a class from 0 to 5, then 5 to 10, like this, right? And we need to see which is the highest value. You can see 32 over here is the highest value, right? So this means we can have the upper class limit till 35, right? So this is how we can infer how many classes we will be needing, how much should be the upper value, because you can see properly they have mentioned that the upper value of a class interval is not included. So this means if we take 35, then 32 will come under this class. So this means our representation will be correct, right? So let's do it now. So let's draw the table first, like this, right? So we need to draw 3 columns, one for telemarks, which will be very helpful, and one for frequency, right? Now let's say we have a table like this, right? Now over here we need to write distances in kilometers, right? And over here we need to write telemarks, and over here we need to write frequency, right? Now over here we need to write distance 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, and 30 to 35. So we have the different classes now, right? Now, first of all, we need to find how many distances or number frequency will come between 0 to 5, right? So this means the value should be less than 5, right? So this means this will come, 3 will come, then 5 will not come because upper value should not be included. So 3 will come. So we have 1. Let's say draw telemark over here, 1. Then we can need to search. We have another 2. So this means second value, right? And we have 3. This means third value, right? Then this is again 3. So this is the fourth value. We need to draw one more telemark over here, right? Then we have another 2. This means 5, right? And no other value is less than 5 now, or right? So this means we have frequency between 0 to 5 as 5, right? So for 5 to 10 we need to search. This means it should be again less than 10, right? So 5 to 10 means 5 is included. So this is 1, right? Then 3 is done, and 10 we can't, 20, 25 no, 11 not possible, 13 not possible, 7 yes, we need to include 7, it's another second value. Then we need to search, we have again 3 values, 1, 2, 3 and 4. So 4 consecutive values. So we need to have 4 values, 1, 2, right, 3 and 4. This means we have now 6 values. We need to count again. This is 1, right, then 2, 3, 4, 5, right. So we have 6 values. Now again we need to count. This is 12, 18, 3. Then we have more values. This is 1, this is 2, right, and this is 3 and this is 4. So this means we need to draw more lines, 1, 2, 3 and 4. So we have 10. We need to search, is there any value left? We need to be very careful. Let's say we can check it again, right. You need to verify each and every time, right. Now over here we have 5 also, so one value is left, it will come in this value, right. So we have one more value, right. So how many are there now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right. So we have frequency as 11, right. Now from 10 to 15 we need not to include 15, means it should be less than 15, right. So we need to count again, right. So we can include this value 10, we have 1. Then we can include this value, this is another value, second. This we can include, this is a third value. Then this is a fourth value, right. 10 we can include, this is a fifth value, right. Then this is a sixth value, right, and this is the seventh value, right. Then we have this value 8, right. 15 should not be there, right. Then 18, this is ninth value, this is 10th value, 9th and 10th, right. And we have this value 11th, right. So again we have 11 as the frequency, right. So telemarks, this is how why telemarks are always important to draw with the distribution table when the data is large, right. Now we have 15 to 20, we need to see how many. Now this means it should be less than 20, right. So again this cannot be included, this cannot be included, right. We need to search, so this can be the value 1, so we need to draw one line over here. Again second, third, right. Then we have this value, we can fourth and fifth, fourth and fifth. Then we have sixth and seventh, sixth, seventh, right. Then we have, need to search very properly, 8th and 9th, right. So 8 and 9, so total is 9 now, right. Now 20 to 25 means it should be less than 25, so there is only one value, right. So we need to draw one telemark and one frequency over here. From 25 to 30 it should be less than 30, right? So this will be 25 only, one value. So one telemark and one frequency table. Then 30 to 35, there is only again one. This is the value. Any other value you can look. You can look properly, right? So this is the one value, right? Let's say we can search properly again. So we have two values, 31 and 32, right? So we have 1, 2 telemarks and frequency as 2. Now when we add this, it should come out as 40. It's a check that we have drawn the distribution table correctly, right? So 11 plus 11 is 22. 22 plus 9 is 31. 31 plus 5 is 36. 36 plus 2 is 38. And 38 plus 2 is 40. So we have distribution table as sum of frequency is correct. So this is 40, right? So this is how we draw the frequency distribution table when the data is large and we need to use the telemarks to make it perfect, or we can say to make a counting easier, right? Now we need to, what are the main feature you can observe from the distribution table? You can see properly we have a two matching frequency of the highest frequency, which is 11 and 11. So we can say that average, or we can say common distance for engineer to workplace is between, we can say, 5 to 15 kilometers. We can say like that, right? It's an average distance, right? And it's also the highest distance. Now, the least common distance is in the between the range 20 to 30, right? So we can write the least common distance is between the range 20 to 30, right? And what is the range of the distance? We need to find the range of a distance. So the range of a distance is, we need to check the lowest distance, which is 2, right? And the highest distance is 32, right? So this means the range will be 32 minus 2, so which is 30, right? So this is how we can infer the information from the tabular form, right? So let's discuss the next question, which is question number 3 and also the last question of this video. Now, it's given that the relative humidity in percentage of a certain city for a month of 30 days was as follows. So this is the relative humidity is given. We need to draw a group frequency distribution table with classes size 84 to 86, 86 to 88, and this was the first part. Second part is, which month or season do you think this data is about? We need to infer, like, is it a monsoon season or what kind of a season is it? And we need to find the range of the data. So this is how these type of questions will generally come in the examination. So you have to watch this part of the video very carefully, right? So let's draw the tabular form first. So let's say we have a table like this, right? And let's say this is the thing, and let's say we write relative humidity in percentage, right? And over here we write frequency, right? Now we need to have a classes size 84 to 86 and 86 to 88, and you need to remember that upper part is not included. You have to be very careful, right? So let's draw the classes, and before that we need to search the maximum value and the minimum value, and the minimum value is, we can see properly, we need to search, right? So 98, these are all 86.5 we can consider. Let's see, we need to compare first, right? 92, right? And we can see properly the least value is 84.5, 9, right? And the maximum value we need to search. So the maximum value over here is, we can see it should be around 90s, in the 90s, right? You can see it can be 99.2, right? So this means our classes should start from 84 and it should end at 100, right? So let's draw it. So it will be 84 to 86, 86 to 88, 88 to 90, 90 to 92, 92 to 94, 94 to 96, 96 to 98, 98 to 100, right? So this is the range. Now we need to count the frequency. Now in 84, there will come only 84.9, so this is the one value, and we need to search for another value which is less than 86. So we need to search, right? So there is no value less than 86, right? So we have only one frequency, right? For 86 to 88, it should come in this range, right? So we need to search. It should be 86 or larger than 86, and it should be less than 88, right? So we can consider this value 86.5, right? Then we can see there is no other value which is less than 88, so we have frequency as 1, right? For next is 88, it should be 88 or greater than 88, and it should be less than 90, right? So let's see it. We can, so this can come, let's say 1, right? Then another value we need to search, right? So we can have two values, right? So this is the number 2. Then from 90 to 92, from 90 to 92, so this is the first value, right? So 90 to 92, so this is the second value. So we have 2, right? Then 92 to 94, we need to search from 92 to 94, so this is 1, right? Then this is 2, this is 3, right? This is 4, then this is 5, it should be less than 94, right? Then 6, right? Now let's do it again. This is, it should be 92, so this is 1, right? This is 2, this is 3, this is 4, this is 5, right? So we have how many values we need to count? So let's do it again. 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, and this is also the value 5, 6, and 7. So we have 7 values. So we need to write 7 over here, right? Then we need to do for 94 to 96. So this means it should be equals to 94 or should be greater than 94 but less than 96. So we need to search 94. So this can be the first value, right? Second, third, right? And this is fourth, fifth, and this is sixth, right? So we have 6 values. Then from 96 to 98, right? So we need to search from 96 to 98. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So we have 7 values, right? From 98 to 100 we need to search. So this is 1, this is 2, then this is 3. Any other more value? This is 5, right? So this we have 4 values, right? So we need to match the distribution frequency summation with the exact number. So it should be 30, right? So let's add it. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 7 is 13, 13 plus 6 is 19, 19 plus 7 is 26, 26 plus 4 is 30, right? So we have 30 as frequency, sum of frequency. This means our distribution table is correct, right? So which is exactly matching with the number of days. Now, the second part says that which month or season do you think the data is about? See, you can see properly the relative humidity is high. So this means the data we can write appears to be taken in the rainy season as the relative humidity is high. So this is the second answer, means it's a rainy season, we can see, because the relative humidity is very high. Now what is the range of this data? This means maximum value minus the minimum value. So we can write the range of data is 99.2 minus 84.9. So when we subtract this, it will come out to be 14.3. So this is how we can use the concept of presentation of data to represent the data in a easily and readable form. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.